Welcome back to Who Wants to Be a Mathematician. I'm your host, Mr. Hill, coming at you with some AP Calculus. In this lesson, we're going to be talking about some velocity and acceleration and how they deal with derivatives. We've been learning a lot about derivatives using the first derivative test, the second derivative test, and all those things. So now we're going to learn about how velocity and acceleration are used. So on the first page of your packet, you have a lot of vocabulary and types of motions and when to use what. So we're going to use this for rectilinear motion, and we're just going to dive right in. So the position function of a point P on a coordinate line is given by that. So our position is going to be this one, and it asks, what are the critical points and points of interest? Points of interest, good. Points of inflection. So critical points are going to be our first derivative. So this is going to be our s prime of t, and our points of inflection are going to be our second derivative, or double prime. So critical points, we find our first derivative, so we're going to have 3t squared minus 24t plus 36. Second derivative, we're going to have 6t minus 24. And to find those, we have to set that equal to 0. So when is this thing equal to 0? Well, we have a quadratic. We notice that we can take a 3 out of each of the terms, so that gives us t squared minus 8t plus 12 equals 0. We factor that out, we're going to get -6 and -2. So t is going to be equal to 2 and 6. Similarly down here, if we set this equal to 0, we're going to get t is equal to 4. So those are our critical numbers. So these are going to be our critical numbers, and this is going to be our number of inflection. So now we need to find the point. So we take that value and plug it back into the original. So to find our point of inflection, we're going to take 4, then we plug that back in, pull out your nifty-difty calculator. We're going to have 4 cubed minus 12 times 16 plus 36 times 4 minus 20, and that gives us a grand whopping total of -4. So now if we do that for our 2, we're going to get 8 minus 48. No, let's do it. So 8 minus 48 plus 72 minus 20, and that gives us 12. And then let's try our 6. So 6 cubed minus 12 times 36. 12 times 36. Oh, having calculator issues here. Minus, there we go, that's what I lost. Plus 36 times 6 minus 20, and we get -20. So we found the critical points, and we found our point of inflection. So in the second part, what does it physically represent? So you have to think, what are we looking at here? Well, when our first derivative is equal to 0, so when our s prime of t is equal to 0, what does that give us? Well, that's representing our velocity, and our velocity is equal to 0. So if our velocity is equal to 0, then we're not moving. It also, if we're not moving, that means we have a change in our position. So change our position, because if we're going this way and then we decide to not move and then we go this way, that's going to be a change in position. So it's going from left to right, or if you think of it, you're in a car, you come to a stoplight, And then you either keep going that way, so that could be one thing that happens after velocity 0, or you could be going this way, you're at the stoplight, you're like, oh, gotta go back, and you go the other way. So it could be a change in that, or when it's not moving. Now, when our double derivative is equal to 0, that means that our acceleration is 0. And if our acceleration is equal to 0, then we have a constant change in position. So, or you could think of that as if we have our a derivative equal to 0, then that's going to be our maximum velocity. Because this is the derivative of velocity, and if we take a derivative, we know we're going to get a maximum or a minimum. So max or min velocity. So that's what they physically represent. So now we have this nifty-difty chart that we have to fill in. And our times that we have to use it for, well, that's going to be when our special times are. So we're on the interval of -1 to 9, so let's put those in there. And we found out that 2, 4, and 6 were other times that are of interest. So if we just scroll up here, we notice that we have 4, 2, and 6. Those are other times that we are interested in. So all we have to do is now fill in the chart for what is the first, or the position of -1. Well, if we just plug it into our calculators, we're going to get 69. And if we plug 2 in, let's see if I can get, so this is, it will be 2 squared minus 36 times 2 minus 20. Oh, that's the wrong one, come on. Silly calculators. We're gonna get 12. Oop! Where did that just go? Nice. So -1, 2, 4, 6, 9, and I forgot what -1 was. So we'll have to just do that all over again. Isn't that wonderful? And now it's going to be -69. And what happens when our position is 4? We're going to plug that in here. We're going to get -4. And what happens when we have 6? We just plug 6 right in. We get -20. What happens when we plug 9 in? This is the most tedious part. We get 61. So that's what we have for our position. Now when our velocity is -1, so now we just need to change the parameters of that. So we have 3 times -1 squared minus 24 times -1 plus 36. This is going to be 63. If we plug in 2 for this, then we're going to get 0. If we plug in 4, we're going to get -12. If we plug in 6, we're going to get 0. And if we plug in 9, we're going to get 63. Now, if we plug it into our acceleration, we're going to get 6 times -1 plus or minus 24 this is going to be negative 30. And we're going to have 12 minus 24 is going to be negative 12. And then we're going to have 6 times 4 minus 24 is going to be 0. And then we're going to have 6 times 6 minus 24 is going to be 12. And then we're going to have 9 times 6 minus 24 is going to give us 30. So using this chart, we're going to fill in this bottom one. So tiny interval. So an interval is going to be from negative 1 to 2. And then our next one's going to be 2 to 4. The different intervals that are going on here. And then we're going to have finally 6 to 9. And then the sign of our velocity graph. Well, if we look from 1 to 2, the sign of our velocity, we're looking at this one here. We notice that 63 is positive, and it goes up to 0. So all of these are positive, so this is going to be a positive number. So if we're in the direction of motion, if we think of a coordinate plane, and this is going to be the positive direction, this is the negative direction, well, this is going to the right, and this is going to the left. And since we're doing rectilinear motion, that's on a line, so we're just going right and left. So the direction of motion is going to go to the right. Now if we look at the sign of our acceleration, well, here we have negative, so that's going to be negative. And if we have positive velocity and negative acceleration, we're going to have decreasing speed. So let's look from 2 to 4. 2 to 4, our velocity is negative, so that means we're going to the left. And our acceleration is still negative. And if we have a negative with a negative, that's going to be increasing speed. Because if you think about it, if I'm going to the left and my acceleration is accelerating to the left, that means that I'm going to be increasing. So now if I come over to 4 to 6, I look up at my chart, I notice that this is a negative and it goes to 0, so I have negative. My acceleration is positive. If I'm negative, then I'm going to the left. If I'm positive and negative, then I'm going to be decreasing my speed. How about 6 to 9? We have from 0 to 63, that's going to be positive. Acceleration is going to be positive. And if they're both the same, then I'm going to be increasing. So fill that out there. Now, all of this is just a whole lot of craziness to say, well, what's really going on here? We take a function, we break it down into our time intervals, then we break it down into what each step does. So if the speed of a particle increases when the sign of velocity and acceleration are the same, if they're both the same, then we're going to have an increasing speed, and it decreases when they're opposite. So we want to describe the motion of P during the interval there. Well, we need to look at from negative 1 to 2. We need to look at from 2 to 4. We need to look at from 6 to 9 and 4 to 6. So if we have these three intervals, our velocity was positive here. It was negative, negative, and positive. So we could say we were moving to the right in this time interval. We're moving to the left. We're moving to the left again. And then we're moving to the right at the end. And then we could talk about the acceleration. This was negative, this was negative, this was positive, this was negative. Or was that positive? I think it was positive. Then we know that we are decreasing, so we are slowing down. We were speeding up. And we were slowing down again. And then we're speeding up. So that kind of describes what's going on. We take our time interval, we talk about where we're going and if we're going faster or slower. So if we're illustrating the path of motion, then we want to talk about, well, we're rectilinear, so we're looking for something that looks like this. And if we come up here and we talk about, okay, so I'm going to the right, and now I'm going to go to the left, I'm going to the left, and I'm going back to the right. So we'll go over more of this in class, but notice that we're making a little squiggly doodad. So let's do an example of what would happen. So if we have our s of t is equal to e to the t minus t cubed. Then we want to determine the direction of motion. Whoop. We want to determine the direction of motion and what the speed is doing, if it's increasing or decreasing. So to find out the direction of motion, we need to take a derivative. So if we look at our first derivative, then we're going to get e to the t minus 3t squared. And we also know that we need to take a second derivative to talk about our speed, e to the t minus 6t. So we're going to set this equal to 0, and that's a doozy right there. So instead of looking for that, I'm going to pull out my nifty-difty calculator. I'm going to y equals, I'm going to type in e to the x minus 3x squared. Then I'm going to go to second graph, so my table function, and I'm going to find out what value gives me a y value of 0, and that's going to be around like 0.95. So when t is 0.95, this is equal to 0. So that's going to be my critical number if we're looking for that. But we're not. We just need to look at our 0 up here, our 0.8, and our 1. So we need to figure out if it's increasing or decreasing at those points there. So if we plug in for our direction of motion, we need to figure out if it's positive or negative. So we're going to do s prime, why are you, okay, s prime of 0, and we're going to get 1 minus 0, which equals 1. So is 1 a positive or negative number? Well, it's positive. So when t is equal to 0, we have a velocity which is positive, so that means we're going to the right. And if we look at our 0.8 and we plug that in, whoop, alright, so we have e to the 0.8 minus 0.8 to the, nope, 3 times 0.8 squared, and that is going to give us 0.3, which is positive. So when t is equal to 0.8, we have a velocity of positive, which is to the right. Whoop. And how about our third one, when it equals 1? Well, we're going to get e minus 3, and we know e is 2.7 minus 3, so that's going to be a negative number. So when t is 1, then our velocity is negative, and we're moving to the left. So that talks about the direction of motion. We found our velocity and we found our direction of motion. Well, now we need to talk about speed. So we need to do the same thing with our second derivative. So second derivative of 0 is going to get us, once again, 1. Our second derivative of 0.8, when we plug that in, we're going to get e to the 0.8 minus 6 times 0.8. Oh, that's not what I wanted at all. E to the 0.8 minus 6 times 0.8 gives me negative 2.6. Our double prime of 1 is going to get us e minus 6, which is going to be negative. So our s prime of 0 was positive. So if we go from a positive to a positive, then we're increasing speed, and we have a positive here, we have a negative here, so that means we're decreasing, and we have a negative here, we have a negative here, so that means we're increasing once again. So that's how we determine that. So now if we look at the displacement, so find the time where the displacement, so if we talk about displacement, we're talking about a change, so we're talking about the derivative. So find out when the displacement, or our derivative function, has the most rapidly changing over the interval. So most rapidly we're thinking maximum because that's the highest. So if we take a maximum, we know that's when it's equal to 0. Well, we already did. That's what we did before when we typed our e to the t minus 3t squared equal to 0 in our calculator, and we got t is equal to 0.95. That's the time at which it's changing most rapidly. So work on the next one, and then once we get back to class, we'll continue the rest of the packet. So work on GP3 by your guys' self, and I'll see you tomorrow.